Good day, grade 11s and grade 12s. I hope you're all doing so well. So today we're going to deal with some various questions from previous question papers, more especially as we're preparing for September trial examination. So let us just start without wasting any time. So Mathematics Paper 2, November 2021, DBE, question 9. In the diagram below, PQRS is a cyclic quadrilateral. So they're telling you what PQRS is a cyclic quadrilateral. P, where is P? P, Q, R, S. They're telling you what is a cyclic quadrilateral. So you're expected to utilize the properties or to utilize the reasons used when proving what a particular quadrilateral is a cyclic quadrilateral. So you're expected to use those rules or the reasoning. Yeah. PS is produced PS is produced to W. TR and TS are tangents. TR and TS are tangents. TR and TS are tangents at point T. Basically, TR and TS. We did this theorem, tangent from the same point. We did that theorem 6. Go back to old videos. And angle T equal to 78, angle Q equal to 93. Then yeah. Then now 9.1, give a reason why ST equal to TR. ST equal to TR. How will you find? How will you solve 9.1, guys? Why ST equal TR? Where is ST and where is TR? ST TR. Remember, guys, they say that TR and TS are tangent. That means according to a theorem that talks about tangents from the same point, it says that if that's the case, then the opposite sides are equal. And if the opposite sides are equal, why they are equal? Because of what? Tangents from the same point. Tangents from the same point, which is point T. So they're just saying to prove or why ST equal to TR. If they're equal, then why they're equal? Because of what? Tangents from the same point. I hope you're gonna grasp that. I hope you're gonna grasp this theorem. Then 9.2.1, guys. Calculate giving reasons the size of S2. S2. Where is S2? Where is S2? Where is S2? Here's my S2, guys. How will I find S2? Remember, guys. Remember, I think now if the two opposite sides are equal, this means the adjacent angles are also equal. This basically means S2 is equal to R2. Because of what? Sides opposite equal angles. I hope you understand. And why do we use that reason? Then how will I find S2 then? Remember, I can use this angle to find these two angles, these two equal adjacent angles, by the use of interior of triangles. Let me just use that one. So I'm going to say S2 plus R2 plus angle T equal 180, reason interior of triangle. Then after that, I'm going to say what's the value of S2? Unknown. What's the value of R2? Unknown. Therefore, S2 plus R2, I leave them on the left hand side, plus what is the value of angle T? 78 equal 180. Then I'm gonna transpose that 78 to the right hand side, and say that okay, my 180 minus 78, how much? 102. Then since S2 equal to R2, I have a right to say okay, they can share this 102 by saying 102 divided by 2 is 51. Therefore, S2 is going to be equal to 51, and also R2 is going to be equal to 51. You do this even only if we have two sides, two opposite sides are equal. If and only if the opposite side of triangle are equal, you can use this type of method to solve for other sides or other adjacent sides that are equal. So even if in the examination, maybe they will say wait, the opposites are equal, and they will just give you the angle. Maybe I will just say angle B, CA. They will give you angle B, and they will say angle B is equals to 35. Let me just say 35. This will mean that by default, angle B is going to be equal to angle C. The reason angles opposite equal sides. That means that angle C is going to be equal to 35. Then you can find angle A by interior of triangle. So this is how you use it, guys. Yes. Then I'm done with 9.2.1. Then let us go to 9.2.2. 9.2.2. 9.2.2. I was just rubbing. 9.2.2. Find S3. Remember, I have S2. S2 is 51. Then what is the value of S3? Remember, guys, remember this angle is outside there. Remember, they say that this is a cyclic quadrilateral, and this angle S2 plus S3 is outside the cyclic quad. Remember, according to theorem, cyclic quadrilateral, it means there are three reasons you can use to find, or there are three reasons you can utilize to prove indeed a particular cyclic quad is a particular quadrilateral is a cyclic quadrilateral. This, therefore, the only way to find S3 is by saying, okay, S2 plus S3, this angle is outside the quadrilateral. This means and we have angle Q. Therefore, I can say S2 plus S3 equal to angle Q. Why? Exterior angle equal to opposite interior angle of cyclic quadrilateral. Then I'm done, guys. Let me just do that, exactly that. So I'm gonna say S2 plus S3 is equals to angle Q. Why? Exterior angle equal opposite interior angle of cyclic quad. Then what's the value of S2? S2 is 51. Then what's the value of S3? Unknown. Then equal to, what's the value of Q? 93. Then obviously I'm going to solve for S3. S3 is equals to, I'm going to say 93 minus that value 51 is going to be equal to 42, guys. Then you are done with this question. I hope you understand, guys. Thank you. Let's go to another question. Okay, guys, another question. This one is so simple. Question number 8 of 2015 preparatory examination, grade 12. Yeah, paper 2. The circle with center O passes through A, B, C, D, and AB is parallel to DC, and BOC is 110. The chords AC and BD intersected E. Calculate DA E2 and prove that BOC is a cyclic quadrilateral. So okay, so they say that AB is parallel to DC, and BOC this angle is 110. Then we have chords. We have chord AC. We have chord BD. They intersected E. So let's find angle D. How will I find angle D? How will I find angle D? Where's angle D, guys? Here's my angle D. Then how will I find angle D? Remember, guys, if you check theorem 2, it talks about angle at center being equal to twice the angle at circumference. So this means if with BC, I can see that it makes 2 angles, if not 3. BC, it makes angle O or angle BOC, this angle that is 110 and BC also, it makes or it subtends angle D. Yeah. This means I can use theorem 2 to find the value of D. I think you can see it, guys. So I'm gonna say BOC, this angle is equal to 2 times angle D, because it qualifies to be, because angle D is at the circumference and angle O is at the center, and these two angles are both made by chord BC. So I can use that theorem 2 now. So I'm gonna say that angle BOC is equal to 2 times angle D. Reason, angle at center equal 2 times angle at circumference. Now what is the value of BOC? Is 110 equal to 2 times angle D. Then I'm going to divide both by 2. Then D is 55. D is equal to 55. I hope you understand, guys. Let us go back to angle D is this 55. Guys, it's 55 here. Yeah? Yes. Then we are done with angle D. How will you find angle A? Angle A. Where is angle A? Here is my angle A. Guys. So there are many ways I can find angle A. I can see that angle A, it is subtended by, say, a BC. Basically, chord BC, it subtends, or angle BC, it makes this angle BOC, and angle A, it is also made by chord BC. Basically, I can use the same theorem 2 to find angle A. Yeah. But also, angle A, it is made by BC together with angle D. Angle D, it is made by chord BC. Basically, I can say angle D is equal to angle A because of what? Angles in the same segment, or angles subtended by the same chord BC. Can you see the butterfly here? BC, angle A, BC, angle D, butterfly. Basically, angle A is equal to 55 because of what? Butterfly, or angles in the same segment. Or can use this theorem number 2 to find angle A. It's not a problem. Therefore, angle A is equal to angle D. Reason, angles in the same segment. Yeah, angles in the same segment. I hope you can clearly see. Then therefore, angle A is equal to 55. Hope you understand, guys. How do we find angle A? Let's go back. 55, 55. Now, E2. How will I find E2? How will I find my E2? How will I find E2? Where is E2? Here is my E2. Guys, now, which, so we need to check which position is E2 in, and even if I can check, okay, one of the ways I can use to find E2 is by trying to find E1 and B1. So I can use angles of a triangle to find E2. Oh, another way I can use, I need to find this angle B2 plus B3 and angle C1. One of the ways I can use is that one, basically. So since I know that we have this triangle, and We know we have the center and we have radii. Basically, these two sides are equal because of radii. Theorem number 1. By default, this will mean that B3 is going to be equal to is C1 plus C2, guys. So I can find B3 and C1 plus C2 at the same time by using angles of triangle because of what? Sides opposite equal angles. So if you have this case with only one angle included, I can use this angle to find these other two angles. I just two other adjacent angles. Yeah? That's what I'm gonna use right now. So I'm gonna say angle BOC plus B3 plus C1 plus C2 equals to 180 degrees. Then solve for B3 and C1 plus C2. I hope you understand the strategy we can use to find angle E2. So let us do that. So BOC plus B3 plus C1 plus C2. And just put it in the bracket to show that it is combined angles. Then resin interior of triangle. Then what's the value of BOC? 110. I don't have B3. And I also don't have C1 plus C2. Then I'm going to transpose this 110 to the right hand side. Then B3 plus C1 plus C2 equal to 180 minus 110 is 70. Then since I have two angles, I need to show that B3 is equal to C1 plus C2. I'm going to divide the two angles. I'm going to divide the 70 by 2 to give me the value of each of these two angles there. So if I say 70 divided by 2 is 35, therefore B3 is equal to 35 and C1 plus C2 is equal to 35. Let's go back. B3 35, then 35. I hope you understand, guys. Then now, what else do I need to find E2? So let us look at this triangle. Triangle BEC. This triangle. Let me just use another color. Let us look at this triangle. BEC. C1. In the triangle, I only need to find angle B2 to find, so that I can find E2. B2 so that I can find E2. So, guys, let's check something here. Yeah. We have parallel lines. As you can see, we have parallel lines. We agree with each other. So I have shape N here. Here's my N. I need to show you this N. I hope you can see it. N, shape N of these parallel lines. Here's my shape N. This shape N or Z, N or Z, I don't know how you see it, but it's Z and N. They're the same. I can see that here I have parallel lines, and according to N, this angle here, according to my Z here, this angle is going to be equal to this angle. Basically, C2 plus C3 equal 55 because of what? Alternating angles are equal. Remember Z and N. I hope you understand how did I come up with that conclusion. I have n and parallel lines. This means okay, this angle here is going to be equal to C2 plus C3, 55. Because of what? Alternating angles. Let us do that. Angle A is equals to C2 plus C3. Reason alternating angles equal such that AB is parallel to DC. AB is parallel to DC. This will mean that C2 plus C3 equal 55 degrees. I hope you understand. Therefore, I can be able to find individual value for C2 since, well, it can be shared, but here I will just show you another time. So the 55 here, then now what I'm left with, since well, I know that I have B3, C1, C2, C3, I also have it. I basically have angle C, all of it, because I have C1 plus C2 plus C3. If I combine the two angles, they're gonna give me angle C. Yeah? Then I have B3, I have angle D, so I can find B2 by the use of this triangle, interior of triangle. Yeah? Another thing that I can use here is that I can see another Z again. Here's my Z again. There we go. So this basically means go to B1 is equal to 55. So basically it was not necessary to go through this, but it's still fine. So I can see that B1 is equal to 55 because of what? Alternating angles are equal. Z. Here's my Z, guys. I hope you can see it. Now, yeah, there's a way now. Okay. Therefore, B1 is equal to 55. Alternating angles equal such that AB is parallel to DC. So now there's light at the end of the tunnel. This means that I can find E1, and I told you it's either I find angle B1 or I find B2 plus B3 and C1 plus C2. I mean, yeah, I promised that, but I now found B1. That means I can find E1, and since E1 and E2 on a straight line, then I can be able to find E2 by angles on a straight line. Let me just do that so that I'm going to find interior of triangle for E1. Yes. So E1 plus B1 plus angle A equal 180. Interior of triangle. Then E1 unknown plus 55 plus 55 equal to 180. Therefore, E1 is equals to 180 minus 55. Is going to be equal to 70. Then 70 here. Then I can find E2 by the use of angles on a straight line equal to 180. So E1 plus E2 equal 180. Angles on a straight line. Then E1 is 70 plus E2 equal to 180. Then E2 is equals to 110. Now, how do we mark? To find how do you mark this question? So, guys, it is 4 marks by the way. So I'm gonna give you if you found the answer. I'm going to give you sorry for that marking in that way. Then you found B1 because B1 is part of this triangle here. B1 is part of triangle BAE here. Then you found E1. Then another thing they can mark is that you found maybe they could give you some sort of a mark when you found angle, or they already given you for angle. Yeah, they could give you for 2 marks for finding here. Then for this one is 2 marks also. For the 2 marks, another mark for statement and reason. Then also this one is 2 marks. Statement and reason. Then for angle, then this one was so unnecessary, but it's still part of the solution. So yeah, that's how they want to mark you the examination. Now the last question for this one: prove that BEOC is a cyclic quadrilateral. Where is BOC? First of all, so you need to recognize where is BOC. So by the way, we now have 110 here. So guys, in the examination you should also clearly indicate on the diagram which value do we have, which values, which known values do we have, which unknown values you don't have, so that they can see what way you're doing, what you're doing. So BOC, where is BOC? BOC or BEOC, this one in a pinky, this one, guys, this quadrilateral. Today we must prove what is a cyclic quad. Remember there are 3 ways to use or to prove what indeed something is a cyclic quadrilateral. There are 3 ways. Other ways is, first way is by use of angles in the same segment when you have a butterfly. Remember, angles in the same segment. Just like when we did with the time we found angle A. We said that BC is subtended by angle A, BC is also subtended by angle D. That on its own is part of proving that a particular quadrilateral is a cyclic quadrilateral. Another way you can use is by having an angle outside that is equal to the angle in the angles, exterior angle equal to opposite interior angle of cyclic quadrilateral. Basically, when you have a cyclic quad, here's my cyclic quad, then I have an exterior angle here. This angle that is outside is going to be equal to angle in the alternating segment. Basically, this angle is going to be equal to this angle. Then if I have another angle on this side, it's going to be equal to this angle here in the opposite interior angles. Then another one is opposite angles of cyclic quad are supplementary. Basically, if you have opposite angles, like if I have B2 plus B3 is equal to, or B2 plus B3 plus angle BOC, this angle, they equal to 180 degrees, or E2 plus E3 plus C1 plus C2 equal to 180 degrees. Basically, the opposite angles of cyclic quad are supplementary. That's another way we can use to prove a particular quadrilateral is a cyclic quadrilateral. So let us prove it right now. Remember, guys, now you don't use those reasoning before you can prove what indeed a particular angle is equal to this angle. You don't use. I will just show you right now. So let us prove on this page. Yes, guys, I can see that we have called BC according to theorem number 3. If you have called BC, it makes E2. BC also makes BOC. It makes this angle. It also makes this angle. What does this mean? And I know that, but it's a butterfly, sort of a kind of a problem here. Basically, I can just use that theorem 3 to prove ukuthi this particular quadrilateral is a cyclic quadrilateral, because I can see that it is visible there ukuthi indeed E2 is equals to BOC. Reason, you don't use angles in the same segment. No. You haven't proven kuti is a cyclic quad. No. Why do I say they're equal? Because they're equal to 110. Each reasoning, you're gonna say each equal 110. You don't use the same angles in the same segment. Then you conclude right now. Therefore, BEOC is a cyclic quad. Why are you saying that? That reason I told you about. Angles in the same segment. Then you are done, guys. You have proven that this is a cyclic quadrilateral. You don't just say angles in the same segment here. No, you're gonna give it wrong because you haven't proven that BEOC is a cyclic quad. You only say that at the end of your solution. Then you are done. Let us go to the last question, guys. Guys, question number 9, which is the last one for this lesson. It's so simple, né? Let's just start without wasting any time. So it says that ABC, this line ABC, is a tangent. Basically, this line to the circle at point B. Basically, at this point, we have tangent. ABC is a tangent at point B. Then from C, a straight line is drawn parallel to the to BF to meet FE. So basically, guys, we have parallel lines here, BF and DC. I didn't draw them, sorry. We have parallel lines here. Yes. Then produced to D. Okay. Then E1 is equals to E2 equal X. Here E1, E2. Then C2 equals to Y. We are done with the statements. We pointed out we have parallel lines and tangent only. We're gonna use those sectors to simplify whatever that we're gonna be asking the question. So yes, man. 9.1, give a reason why each of the following is true. Basically, you must just give a reason. They've given a statement, you must just give a reason when as a person or as a student. So B1 equal X. B1 equal X. Where's B1? Here's my B1. You must prove what B1 is equals to X. How will you prove that? Where is X, by the way? We have X here and we have X here. How will you make sure that B1 is equal to either E1 or E2? How would you prove that, guys? How will you prove that? Since, well, they told us that at B, this line is a tangent. That means, according to the theorem 8 of Tancred, it said that an angle between a line and a chord, an angle between a line and a chord, this chord, is equal to angle in the alternating segment. Basically, this angle between this line and this chord, which is B1, is equal to the angle that is made by that chord. Chord BF, which angle does chord BF subtend or make? E1. BF, it makes E1. That means B1 equals to E1. Ne? Reason, tangent chord, tan chord. I hope you understand, guys, tan chord. So in the examination, I just find where you see Z. Ne? In this way, here's my Z, by the way. Here's my Z. So this Z is equal to this angle here. Ne? The inside of Z and the outside of Z. This is my outside of Z. It's equal to the inside of my Z. I have just memorized tan chord in that way because this theorem was so difficult for me. But right now, I've just mastered it because when I see Z and the chord and the line, I can see that, okay, where is my, I just look for my Z in J, then I'm fine. But you must look for Z in a proper way, guys. Don't just look for Z in J where there's no tan chord theorem in the diagram. Or they need to look in cycle geometry. For you to master cycle geometry, you need to understand the statement. You need to know from the statement which theorems are included in the statement. So you don't just apply theorems that are not included in the statement. So you ought to understand and know which theorems are there in the statement, or are there in the instructions. You want to apply what you have in the instruction. You cannot just apply circle and cyclic quadrilateral. You can see that there's a quadrilateral here. They need to tell you this is a cyclic quadrilateral, or they need to tell you you must prove indeed this quadrilateral is a cyclic quad. You don't just use the properties of quadrilaterals or cyclic quadrilaterals in this example, even if without them instructing you here. They need to tell you first, here is a cyclic quad, this and that and that. If they didn't tell you, just leave everything. Use what you have been told from the instruction. You utilize what you have been told. This theorem is involved in the structure. It can be used on the diagram. It's finished and clear, guys. I hope you have captured my advice with regards to cyclic geometry, how to perhaps master it. Well, one of the ways you can master it is to understand and apply what you are given. Do not apply what it is not in the instruction or on the diagram, basically. Yes. BCD equal B1. Where is BCD? Angle BCD. B, this angle. This is basically angle C1 plus C2. This all this angles, including C1 plus C2, which we must prove is equals to B1. Basically, angle C, all of it is equals to X. How do you prove it, guys? I can see that I have my parallel lines here, and I can see in grade 9 we dealt with fan, the shape fan. Fan, F for corresponding, U for cointerior angles, then N or Z for alternating. So I can see that there's F here, and BF is parallel to CD. Therefore, if that's the case, then B1 is equal to angle C, all of it. Reason corresponding angles are equal. I hope you understand, guys. Corresponding angles equal, such that BF is parallel to CD, guys. This will mean go to angle C equal X, and angle C1 equal X minus Y. How did I find it? I said C1 plus C2 equal angle C, all of it. Then, since I didn't know what was the value of angle C1, I just said, okay, for me to find C1, I need to subtract Y from X. I'm going to be left with X minus Y. I basically said, okay, I said C1 plus C2 equal angle C. Then what's the value of angle C is X, and what's the value of C1 unknown, then C2 it is my Y. Then I transpose this Y to the side. It's going to be X minus Y equals C1. Hence my C1 is X minus Y. Basically, I'm just filling up some information for future references. Maybe they could ask you must find C1, and already I've just explained it right now, so we just write it in J. Then 9.2, prove that BCDE is a cyclic quadrilateral. Prove that BCDE is a cyclic quadrilateral. Okay, so simple, ne? Very, 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 very simple, guys. Such questions are so simple. So they are saying you must prove this quadrilateral is a cyclic quad, and you know the properties of proving a particular quadrilateral is a cyclic quad, ne? So go back to those three properties you're instructed to use when proving quadrilateral is a cyclic quadrilateral. So don't just do things. Just go back to those theorems. I'm not going to teach you. Just go back to the video we have posted on this channel. You understand where we come from with regards to those theorems, all of them. So we have three theorems, by the way, guys. The first one is the reason you can use to prove a particular quadrilateral is a cyclic quad is angles in the same segment. Basically, if we have BC here, if BC subtends E2, BC, if and only if angle, by the way, guys, it's D1 here and D2 here. Yes. If and only if D2 was X, then I'll just say, okay, therefore this quadrilateral is a cyclic quad because of what? Because D2 is equals to E2, which is equal to X, each equal to X. Then my conclusion is going to be, therefore, this quadrilateral is a cyclic quad because of what? Angles in the same segment. You don't just say angles in the same segment without proving that D2 equal to X indeed. Remember, chord BC, it makes E2, and chord BC, it makes D2 also. Angles obtained by the same chord or angles in the same segment. Another one you can use is angles, opposite angles are supplementary. Opposite angles of cyclic quad are supplementary. Basically, E2 plus E3 plus C1 plus C2 equal to 180 degrees. Or another one, you can just say B3 plus B4 plus D1 plus D2 equal to 180 degrees. You just utilize what is visible on the diagram. Just try the simplest way you can simplify this problem. The last one is if and only if you have an angle that is outside the quadrilateral. Exterior angle equal opposite interior angle of cyclic quad. Basically, I can say E1 equals to angle C, because E1 is an exterior angle of this quadrilateral. And also B1 plus B2 is equals to D1 plus D2, because B1 plus B2 is an exterior angle of this quadrilateral. Guys. So which between those three reasons, which one is suitable we can use in this diagram? Which one is so suitable that you can use? Which one is so suitable? I can use the opposite. I can use this one of saying, okay, right now I only need to find E3 here. Here I only need to find E3. And how will I find E3? By saying E1 plus E2 plus E3 equal to 180 degrees. Why? Angles on a straight line. Then after I have found E3, I'll just say E2 plus E3 equals to C1. I mean E2 plus E3 plus C1 plus C2 equals to 180 degrees. Basically, I'm proving that if I add E2 plus E3 plus C1 plus C2, they're going to give me 180 degrees. I'm proving that. Before I can say they're indeed equal to 180 degrees, I need to prove that if I add them only, not by equating them to 180, but if I only add them, will they be equal to 180 degrees? If yes, then okay, therefore, this quadrilateral is a cyclic quad because of what? When I add opposite angles, they are equal. I mean, they are supplementary. The other one that I can use, I can say, okay, E1, since I found that angle C equal to X, therefore, angle E1 is an exterior angle. This angle E1 is going to be equal to angle C. Why? Each equal to X. Then, therefore, this quadrilateral is a cyclic quad. Reason: exterior angle equals to opposite interior angle of cyclic quadrilateral. So I have two ways to simplify 9.2. Solution is so simple. This one is so easier to find. To say that, okay, E1, since we have found angle C, which is equal to X, I can say E1 equals to angle C, each equal to X. Let me just write it down, guys. 9.2, let me just write it here. 9.2, E1, angle E1 equals to angle C. Why? Each equal to X, here. Each equal to X, guys. Then therefore, I know that if this is the case, then B, C, D, E is a cyclic quadrilateral. Reason: exterior angle equal opposite interior angle of cyclic quad. Then I'm done with 9.2. When in your own space, just find E3. After you found E3 by angles on a straight line, then you're gonna just say E2 plus E3 plus angle C plus X. Will they give you 180 when you add them? Even if they give you 180, then just conclude on this. Yes. Let me just, okay, I'll just do it next time. Let me just do it and let me just show you another way you can use to find or to prove that this quadrilateral is a cyclic quad. Let me just do it on the side in fella here on a roughly so E3, how much is E3? I'm gonna say x plus x is 2x, then I'm gonna say x plus E3 equal 180 angles in a straight line. Then x plus x is 2x, then I'm gonna transpose 2x to the side of 180. I'm gonna be left with E3. Therefore E3 is going to be equal to 180 minus 2x. You can just do it by yourself, guys. And I'm just showing you other ways you can use to find 9.2, to basically prove 9.2. Then I'm gonna say, okay, E2 plus E3 plus angle C. Good. You just add what do we have. Then for E2 I have x, for E3 I have 180 minus 2x, then for angle C I have x. Then x plus x is 2x, then 3x minus 2x is 0, then I'm left with 180. Therefore, I have added E2 plus E3 plus angle C. They give me 180 if I add them. Therefore, I conclude, therefore, BCDE is a cyclic quad. Reason, opposite angles of cyclic quad are supplementary. Then I'm done, guys. This is the another way we can use to find 9.2. Then the last question, 9.3. Prove that B2 equals to C1. B2 equals to C1. What's the value of C1? We have found C1 here. Remember, x minus y. Meaning, I need to prove that B2 is equal to x minus y. How will I prove that, guys? How will I prove that? So simple, ne? So simple. I think it's so simple to prove that B2 equals to x minus y, ne? One of the ways you can use to prove that B2 is equals to C1 is by at least finding the value of f only. How will I find f? I know that angle B, like this line is a tangent, and I know that B3 plus B4 equals to angle F, tan chord, remember? So how will I find B3 and B4? Since I know that BCDE is a cyclic quadrilateral, I've already proven that. Therefore, I'm eligible to use the properties of cyclic quadrilateral, or the reasons that are used in the cyclic quadrilateral space to find other values that are included in that cyclic quadrilateral. So you can see I have butterfly here. When I have angular subtends, even if I can look at chord DC. Chord DC is subtends B4. It also subtends E3. This means that E3 equals to B4. Why? Angle subtended by the same chord DC. 180 minus 2x. DC subtends B4. DC it subtends E3 also. I hope you understand, guys. Then how will I find B3? B3 also, if I can look at the chord ED. Chord ED it makes B3. Chord ED again it makes C2 specifically. Therefore C2 is equal to y. This will mean that B3 is going to be equal to y. Then since I know that I have a tangent there, that means we go to B3 plus B4 equals to angle F. I'm going to add 180 minus 2x plus y. They're going to give me angle F. What is the value of 180 minus 2x plus y? It is 180 minus 2x plus y. This is the value of F. Then now I can use interior of triangle to find B2. I can use interior of triangle to find B2. How will I find B2? Interior of triangle. Therefore, we'll just say angle F plus B2 plus E1 equal 180. Reason interior of triangle. What's the value of angle F? 180 minus 2x plus y. 180 minus 2x plus y plus B2 unknown plus E1 x equal 180. Then I'm going to transpose each and every value to the right hand side so that I can be left with B2 on the one side. So 180, it removes 180. Negative 2x plus y is negative x. Then if I transpose negative x to the right hand side, it's going to be positive x, then y, if I transpose y to the right hand side, is going to be minus y. Therefore B2 is equals to x minus y. And remember, C1 is equals to x minus 1. Therefore B2 is equal to C1. Raising each equal x minus y. Then you are probably done, guys. I think like you are done. Then with that being said, I can just further my question by saying, how will I find D2? How will I find D2? D2. I know this question is not asked, but for the sake of other people who are curious in terms of finding D2, I'll just help you right now. D2 is obtained by chord BC. Basically, chord BC, it makes C2. Chord BC, it also makes E2. That means D2 is going to be equal to X. Angles obtained by the same chord. Then how will I find D1? D1 is so simple. I can look at a chord BE. BE, it makes C1. Then BE also makes D1. This will mean D1 is going to be equal to C1. What's the value of C1? X minus 1. Then we are literally done because we've found each and every angle inside this circle and outside of it, obviously. Then guys, I hope you are proper wherever you are, grade 11 and grade 12 most specifically. This question paper is of metric 2016, if I'm not mistaken. Yes, question 9 2016, November examination. Yes. So thank you guys. I hope you're gonna enjoy your day, and we are left with a few weeks before we proceed or start with our preparatory examination in September. So I hope you have subscribed to the channel as we are preparing for final examination in November and preparatory examination here now in September. So let us fight and strive for a proper education wherever you are. Thank you, matriculants. Enjoy your day. Is well.